Hi friends, in this video we will discuss about the demodulation of the FM by the phased looped loop method as we promised in the last video. In the last video we discussed about the slope detector method for the demodulation of the FM. In that we use the transformer, as we know that the transformer are the bulky and the expensive. So PLL is the device that eliminates the needs of transformer in the FM demodulation. It is also used in the radio equipment, broadcast application, and the frequency synthesizer and the tone generation. There are three main blocks in the PLL: phase detector, active low pass filter, and third one is VCO. VCO is the voltage control oscillator. This is the diagram for the PLL, in which input signal and the output of the voltage control oscillator goes as the input in the phase detector, that is followed by the low pass filter, which output amplified by the amplifier, and the message signal is goes again into the voltage control oscillator. Working of PLL: when the two input signal of the different frequencies or two input signal have a phase difference, goes as a input to the phase detector. Phase detector detects the difference between these two input signal frequency, and according to that difference it generates some voltage signal, and that will filter by the low pass filter, and amplifier amplifies that signal, and this output signal goes as an input to the voltage control oscillator. As we discussed earlier, voltage control oscillator, according to the message signal amplitude, its generate frequency, and generated frequency FVCO again compare with the FI, and in the last the difference of these two frequency will be set to 0. This is the basic function of the PLL, in which we minimize the difference of two input signal, and we generate the message signal amplitude according to that. There are three modes of the PLL: free running mode, capture mode, and the lock mode. In the free running mode, we do not apply the some input signal to the phase detector. By the some voltage control oscillator, VCO generates some frequency, and this it goes to the phase detector, and then low pass filter, then amplifier, and this process continue. This is the free running mode. And in the capture mode, we apply some input signal, and by some voltage control oscillator signal it generates some frequency, and PLL try to capture the input frequency Fi, that is the capture mode. And in the log mode, the input frequency Fi is equal to the voltage control oscillator frequency FVCO. Now the working of PLL in the demodulation of the FM signal, that is the one application of the PLL. In the PLL, we apply the resultant frequency modulated signal as the input to the phase detector, and some voltage control oscillator generates some frequency FVCO by the voltage control oscillator, and these two frequency goes as an input to the phase detector. Phase detector is basically work as a balance modulator, and we discussed earlier in the generation of the double sideband suppressed carrier that balance modulator is work like a multiplier. So when we apply two input signal as a input, it basically multiply the term. So by default in the communication field, some input signal that we apply is as a sinusoidal signal. So when we multiply two sinusoidal signal of frequency Fi and FVCO, so this will be 2 sin FIT and sin FVCOT. Then the resultant by the phase modulator is as a cos Fi minus FVCO, and one term is cos Fi plus FVCO. So this will passes to the low pass filter, and because low pass filter allows the DC term and the low frequency term, so output of the low pass filter is Fi minus FVCO, which amplify by the amplifier, and according, and the one function of the phase detector is according to the phase difference, it generates the message signal amplitude. So that message signal goes as a input to the voltage control oscillator, and voltage control oscillator according to the message signal input amplitude, it's generate the frequency. So that generate the frequency FVCO. Then it's again compare with the input frequency Fi, and in last these two frequency will be equal, or we say that Fi is equal to the FVCO. Let's suppose that the input signal has a frequency Fi, then in the frequency modulated signal we know that the input frequency Fi is given by Fc plus Kf mt, where mt is some modulated signal, Kf is the frequency sensitivity, and in the voltage control oscillator generated frequency FVCO is equal to F0 plus KVCO into VCT, where VCT is some voltage control signal and KVCO is some frequency constant, and F0 is the free running frequency of the VCO. And as we know in the phase detector, in the last FVCO is equal to the Fi. Then we equate these two term equal. So F0 plus KVCO into VCT is equal to the Fc plus Kf mt. Then the VCT is equal to Fc minus F0 plus Kf mt by KVCO. In the PLL, for to be in the lock mode, Fc is equal to the F0. Then the VCT is equal to the Kf by KVCO into mt. Then we compare this equation by the linear equation, that is y equal to mx. So Kf by KVCO is work as a slope or some constant. So the voltage control signal is directly proportional to the message signal, or we can say that the voltage control signal that generate is linear to some input signal. So it's follow the linearity. As we discussed earlier that in the slope detector output is in follow the non-linearity, so there is some error in the output message signal, but here the message signal follow the linearity, so there is no amplitude noise. So this is the one advantage of the PLL, and we can easily make the IC of the PLL, so the manufacturing cost of the PLL is very less. These are the some advantage of the PLL.